In the earlier four parts, part 1, 2, 3, 4, we discussed almost everything, almost all the concepts required for infinite series to check convergence, or means to check the convergence, whether the series is convergent or divergent. So many things we discussed, all the things we discussed at the end of part 4 I discussed. Let us start now part 5. These are miscellaneous things, means some missing things which we didn't touch that. One is comparison test. Try to see carefully. I am writing comparison test, not limit comparison test. Without limit, it is just a comparison test. What is this comparison test? You see, if un and vn are sequences of positive terms, how are they? Sequences of positive terms, and un is less than or equal to vn, means every term of this sequence is less than corresponding term of this sequence. u3 of this is less than v3 of that. Where is that I written? Oh, I have written this, sorry, vn. So u3 is less than v3, u10 is less than v10, like that. Means every term of this sequence is less than corresponding term of that sequence, second sequence. Is this point clear or not? If this is the situation and sigma vn is convergent, then sigma un is also convergent. This is just as per common sense. I'll tell you what is the meaning of sigma un vn convergent. You tell me. I said in earlier part. Don't say vn as element. Sigma vn means v1 plus v2 plus v3 so on. The sum of all the infinite number of terms is a unique finite quantity. Finite number, unique finite number. Instead of saying quantity, let us be specific, say that it is unique finite quantity. Why I am telling every time unique? Did you note it? I was saying unique. For example, I have just this much sigma minus 1 power n. How will be the terms of the sequence? You tell me. Series, how is this series? First it will be minus 1. Okay? Plus 1. Plus minus 1. Means I am writing plus in between. I am alternately writing minus plus so on. Tell me, what is the total of all these steps? Can you tell what is the total of this? You are cancelling this 2 and saying 0. But 1 will come afterwards. It will become 1. Again it will become 0. So the total is either 0 or you are not clear. In the dilemma you are. Whether it is 0 or whether it will be 1. So it is fluctuating between two numbers. So it is not having a unique finite number as the sum. Therefore it is not convergent. Back to the point. If it is convergent means you know the total of all the terms. It's a unique finite number. Okay. If this is convergent, how is sigma un? This un is less than vn, no? So I'll write it simply. v1 plus v2 plus v3 plus so on. This is convergent. This is the situation. So if that is convergent, U1 is smaller than this V1, no? U2 is smaller than V2, so on. So if I add this, will this summation be less when compared to this? And that is itself finite. Therefore this is also finite. I hope you are clear. So if it is convergent, then smaller than that will be convergent. If it is convergent, smaller will be convergent. This is just a comparison test, no limit calculation, nothing. Comparison test. This is one situation. Second situation is if same things, okay, instead of saying all, I'll just simply mention here itself are sequences of positive terms and this one. Then I will write then and then include this completely. Same thing I'm writing, I want to make two bits here. So number one, sigma un is convergent if, come and tell me, this is convergent if sigma vn is convergent. Just now I said no. So the smaller infinite series is convergent if the bigger one is convergent. Next, second bit, what can we say under this condition? Very important, comparison test. Which is bigger, which is smaller? Sigma vn is bigger, sigma un is smaller. If this smaller one itself divergent, means the total is infinity, for example, then this is bigger than that. Therefore, that will be however divergent. So, what is the condition I should write it? No, not that counter positive. Simply, if that is convergent, this is convergent. I have written like this. If that is convergent, smaller one is convergent. If smaller one is divergent, bigger one is divergent. Only these two things we can tell. So what is that now you tell me? If will, I will write if here. Sigma Vn is divergent, convergent, then this is convergent. We are written. So sigma Vn is divergent if, come on tell me, that bigger one is divergent if smaller one is divergent. So sigma Vn is divergent if sigma Un is divergent. I hope you are all clear up to here. Is this point understood? Now you have to be careful about one thing. That careful point is, if it is convergent, smaller one is convergent, bigger one you cannot tell anything. Smaller one is convergent, bigger one you cannot tell anything. And if bigger one is divergent, smaller one you cannot tell anything. Actually, four things are possible, no? Four things. One is small, one is big. This is convergent, then telling about that. This is divergent, then telling about that. That is convergent, telling about this. That is divergent, telling about this. Four possibilities are there or not? Out of four possibilities, we can give guarantee of only two things. That is, if smaller one is divergent, bigger one will be divergent. If bigger one is convergent, smaller one is convergent. I'll tell you a simple example. Okay, keep it in mind, that simple example. That room door is there. If the height is, for example, 6 feet. What is the height? 6 feet. You brought an almirah, that is 7 feet. That's not going from there. Not going. If it is not going, think divergent. Think divergent. If 7 feet almirah is not going out, whether 8 feet almirah will go? So if the smaller one is not going out, bigger one will not go out, that is sure. Means what? If smaller one is divergent, bigger one is however divergent. Now, you brought an almirah inside, that is 5 feet almirah suppose. What about 4 feet almirah? When 5 feet almirah has come, further small will come or not? So when Vn is convergent, sigma Vn is convergent, then this will however come. But now comes very important issue, that is, that height is 7 feet. Almirah you don't know how much it is. Just you are trying to take it out. It's not going out. Means you are not able to take it out. Means it is divergent. What about the smaller one? It may go, it may not go, because if that height is 5 feet, this is 6 feet outside, no 6 feet, you brought for 6.5. That is not going out. If you bring smaller one, that smaller one may be 5.5, that may be 6.25. Less than 6.5 is, door is 6 feet. First almirah is 6.5. 6.5 is not going out. Less than 6.5 you are trying. That less than 6.5, maybe 6.25, maybe 5.5. For example. So 6.25 will not go out, but 5.5 will go out. So you cannot give the guarantee about smaller one. When bigger one is divergent. When bigger one is divergent, smaller can be convergent, smaller can be divergent. I hope you are clear. If smaller one is convergent, bigger one may be convergent, may be divergent. But bigger convergent, smaller convergent, sure. Smaller divergent, then bigger divergent, sure. I hope I have justified my point here by giving that simple example also. So are you all clear about these points? Let's have a very short revision of all the concepts which we have studied. This is part 5. Better it is that we will end up the part here, and problem solving session we will definitely do it in the next class, because time is not permitting now. What is the time now, you check it? 3? Okay, good. 3:46 now. So what to do? In 5 to 10 minutes we cannot do that complete problem solving session. So what we will do better? No. Next class we will take up the problem solving session. Right now what we will do? Short revision of all the topics which we have discussed. That will definitely help you. Come on, tell me. Shall we do it or not? Good. Chalo, fine, stop. Photo not taken, no? Only one thing I have written, no? I'll just repeat it, you take it. Or else you watch the video, write that one. When I say that, then stop it and write it. Good. Back to the point. At least do some hard work sometimes. So now, revision. Chalo, come on. Let us do the revision in a very short time. Maximum, how much time? 5 minutes. Maximum 5 minutes we have to finish. It is 3:48 now. At 3:53 we have to stop. First, sigma r power n. What is the name of this series? Geometric series. Example, sigma 1 by 3 whole power n. What is the r value? 1 by 3. That is less than. Better talk about mod r. This is mod 1 by 3 less than 1. So what is the declaration? Convergent. When r is less than 1, mod r is less than 1, then only it is convergent. If it is 1 or greater than 1, divergent. Okay, no need to give another example. Next, second point. Sigma 1 by n power p. This is called p series. Example, sigma 1 by root n, for example. What is this? It is like sigma 1 by n power half. So p is how much? Half. This is less than 1 or equal to 1, it is divergent. Greater than 1, it is convergent. So this is divergent. So This is over. Next we are done for limit comparison test. I'll not write full what you say English sentence. If sigma un and sigma vn are two series of positive terms, and what is the condition? Limit of un by not equal to 0. What is the conclusion then? Sigma un comma sigma vn are of same nature. Both will be convergent or both will be divergent. Given series you call sigma un. From un you take up common from numerator denominator, cancel that, net power will come, that you take as vn, then calculate limit of un by vn, all these things. Both will be of same nature. What is the main important condition? Limit of un by vn should not be 0. Whatever number comes, no problem, but it should not be 0. Are you following? When this limit comparison test should be applied? When un is, whatever un is, for example 2n square plus 1 by n plus 2 into n plus 3 into n plus 4, for example. It is a polynomial, second degree polynomial. It is a third degree polynomial. Polynomial by polynomial. Then only you test this. Otherwise, actually in some other situation also it is useful, but better apply it surely in the case of polynomial by polynomial. So over. Next comes ratio test. Ratio test. If sigma un is a series of positive terms and what is the calculation? Limit un plus 1 by un, n tends to that limit is equal to L. Depending upon L value, decision will be taken. What are the three possibilities? L less than 1, convergent. L greater than 1, L is equal to 1, not 0. Who said 0? L is equal to 1, test fails. If ratio test fails, we have to use Rabi's test. Rabi's test. When un plus 1 by un does not involve e, I said earlier, right? In the previous parts I said. Over. Is this clear? This is ratio test. When ratio test should be used? When un contains factorial or like factorial, so on concept is there in un, so on. Then only touch this ratio test. Coming to next, root test. What is that root test? Come on, tell. Root. Same, sigma un is a series of positive terms and limit n tends to infinity un whole power is equal to L. Same thing, same conditions. So I am just attaching that here. Same conditions. This should be used when un contains n as power. So n should be used as power in un. Then you apply ratio test. Sorry, root test. Sometimes if you are in confusion whether ratio or root, best choice is to go for ratio. Keep in mind. If you are unable to understand what to do, apply ratio test. It is very powerful test. Now, if it fails, there is one more special. What is that? Okay, take the photo of this one fast, quick. Done. It is 3:53 now. We have finished so many things. So come on, Rabi's. What is Rabi's test? Point number 6. Rabi's test. Same, un is a series of positive terms and limit. What is the limit here? un by un plus 1. Reverse. Minus 1. N is multiplied. N tends to is equal to L. Conditions are opposite here. L less than 1, convergent. Sorry. Divergent. L greater than 1. L equal to 1. Test fails. Clear about this one all? Okay. So next, The last few points. Okay, what is the shortcut for divergence? Limit n tends to, this is shortcut. For polynomial by polynomial, un is polynomial by polynomial same degree. Then use shortcut. Come on, tell me what is used here? Un limit not equal to, then sigma un is Pranay. It is divergent. Limit un not equal to 0. If limit un is 0, we can't decide anything. Next, coming to the last concept, that is alternating series. How it will be? Sigma into un. This is alternating series. There are two types of convergence. Absolute convergence. When do you say absolute convergence? Sigma mod an is convergent. Enough. Okay. What is conditional convergence? Sigma an is convergent and sigma mod an is divergent. Then it is called conditionally convergent. And the last thing which we have tested, that is comparison test. What is comparison test? Just now we discussed, no need of revision. Just now we discussed. Bigger series is convergent, smaller one will be convergent. Smaller one is divergent, bigger one will be divergent. So we will see the problems in the problem solving session in the next part. So this is which part now? 5. Part number 5. In part number 6 we will see problems. Good. Fine. Take the photo.